My dear students, I welcome you all to Chakri Academy. In today's session, I have taken one very important concept of capacitance. Basically, we are going to discuss the energy stored in a capacitor. So in this topic, they ask a very specific type of question that once the capacitor is charged by a battery, once the capacitor is charged, you remove the battery and you replace that battery with an uncharged capacitor. So you need to find out what is the difference in the energy in the initial case and the energy stored in the second case. And you need to write down the reason that why there is a difference in the energy in both the cases. This is a very common question in your board exam as well as your entrance exam. So that is the reason I am taking this topic in today's session, so that after seeing this session, all your doubts are clear. So as you can see the question, we have a 900 picofarad capacitor, which is charged by a 100-volt battery. Now, first you need to find out, because of this battery, how much energy will be stored in this capacitor. Second part is, once this battery is removed and you connect a new capacitor in the place of battery, what will be the new energy stored in the system? So the second figure, if you observe, I remove the battery and replace the battery with a capacitor, right? So as of now, you ignore that charge. You just assume that two capacitors are connected. The first question what comes to our mind, that this connection is series or parallel. Most of the students are confused. They're not able to identify whether this is series connection or parallel connection. Just observe one simple thing. The positive terminal of this capacitor is connected to positive of this capacitor. Negative terminal is connected to negative of the second capacitor. So this kind of connection is basically parallel. Positive to positive, negative to negative. So that is also not clear. I will tell you one more method. What you do, you mark a particular point here. Suppose you mark this point as A and you mark this point as B. If you see that the left plate and the left plate here both have the same terminals A, the right plate and the right plate of this have the same terminal B. Whenever two components have the same terminals, or you can say same starting point and ending point, what is that connection called? Parallel connection. First question is whether it is series or parallel. Answer is parallel connection. Now, the capacitor what I have connected is identical capacitor. This was C, this is also C. Now, the moment you connect this uncharged capacitor to a charged capacitor, what will happen? The charge will start flowing from the charged capacitor to the uncharged capacitor. But the question is, up to what time? There should be a time limit, right? So charge will keep on moving, or charge will keep on distributing until and unless both the capacitors have the same potential, which is called common potential. So the moment these two capacitors attain a common potential, you can say that will be a stable scenario, equilibrium. So the charge distribution will stop at that time. So let's identify how to find out the charge distribution on both the capacitors and how to identify the common potential. So let's start solving it. So our first part is, what is the energy stored initially? So what is the initial energy? Half C V square. What is the capacitance given? 900 picofarad. Pico means 10 to the power minus 12. And what is the potential given? 100 volts. Let's substitute it here. So once you do the calculation, this is half into 900 into 10 to the power minus 12 into 10 to the power 4. So if you see, 9 by 2 is 4.5. And this will be how much? 10 to the power 6 and 10 to the power minus 12, which is 10 to the power minus 6 joules. This much energy is stored initially. Now I remove the battery and place the identical capacitor. What will happen? Charge will start moving from the charged capacitor to the uncharged, and it will flow up to which instant, it will distribute up to which instant, the time at which both of them will have the common potential. So how to find the charge on both the capacitors? Like I told, both of them are in parallel. So potential across them will be same or different? Same. Right? Since you have understood their parallel connection, you can say that a potential will be same. So I am taking this as the first one, this one as the second one. So Q1 by C1, that is the potential across the upper capacitor, will be equal to Q2 divided by C2, That is the potential across the second capacitor. Both of them will be equal because it is parallel connection. You know that C1 and C2 are same because I have connected an identical capacitor. C1 and C2 is same. So we get charge on first one is equal to charge on second one. Correct? Now, you need to keep in mind that the law of conservation of charge will hold true. Total charge of the system will remain conserved. So, total charge. So, Q1 plus Q2 will be equal to Q. What is Q? The charge, initial charge, initial charge. So, both of them are equal. So, 2 times of Q1 or 2 times of Q2 will be equal to Q. So, Q1 will be equal to Q2, which is Q by 2. So how the charge will get distributed? Equally. So what is the point you have understood here? That if both the charges, not charges, sorry, if both the capacitors are same, charge distribution will be equal. But what will happen if capacitors are different? That I will take in the next question. So if capacitors are identical, then the charge distribution will be half of initial charge. So that is the reason Q by 2 and Q by 2 is written here. Now what will be the new potential? Since Q is equal to C, correct? Q is equal to C. So what I'm telling that new charge will be equal to capacitor into new potential. C is the capacitor, right? Capacitor is not changing. So new charge is equal to capacitor into new potential. And what is that new potential? Common potential, correct? So Q dash is how much? Q by 2. The charge is Q by 2. So Q by 2 is equal to C times of V dash, correct? What will be V dash? What will be V dash if you solve? So V dash will be equal to Q by 2C. So what is Q by C? Potential. So V dash will be equal to V by 2. So this will be the common potential or the new potential. I'm teaching you the whole method that how to find the charge, how to find the common potential. Okay, there is a trick also, but the thing is that you know to know the method. So what is the trick here? If the capacitors are same, charge distribution will be half and potential will also become half of the original value. And that's what you can see here. That is the trick. Okay, but method is in front of you. So we used potential will be same because parallel connection. And the second thing what we used is law of conservation of charge. The new charge will be same as original charge. These two things we use. Now, what is the final thing we need to find out? We need to find out what is the energy, right? What is the final energy? So E final will be equal to what? Half, correct? CV square, half CV square. So you can use half CV square as well as what can you use? You can use half into Q into V, anything. So half CV square. So C V square. So what is V? V by 2. So this is for one capacitor. Don't do the mistake of not writing 2. This is the energy stored across this one. We have 2. So we'll multiply the final expression by 2. So we'll write 2 also here. So simplify this. 2 and 1 by 2 gets cancelled. So what do you get? 1 by 4 CV square, correct? So what can we write this as? 1 by 2 times of 1 by 2 CV square. If you observe, our final energy is half times the original energy. So if they ask you what is the ratio between initial and final, energy is becoming half. So what is half of 4.5? 2.25 into 10 to the power minus 6 joule. That is the final energy. Now the next question is that what is happening to the energy? What is happening to the energy? Energy is becoming half. But what happened to the remaining half? Where did that energy go? So the reason is when you remove the battery and connect a similar capacitor here, what is happening? The system is going to a steady state, right? Or you can say in simple words that charge distribution is happening from the charged capacitor to the uncharged capacitor. Charge distribution is happening, and this period is called transient period. When the charge distribution is happening until unless it achieves a common potential. So this period is called transient period. And in this transient period, there is a current flowing which is called transient current, because of which there will be a heat produced and there will be electromagnetic radiations. So the remaining energy is lost in the form of heat and electromagnetic radiation because of the transient current which is flowing during which time interval? When the charge distribution is happening. This is a simple explanation, but a lot of concepts have been basically explained to you in this one question. So you need to pick these kind of question where from one question you learn multiple concepts. So let's take one more similar kind of question where both the capacitors will not be same, they will be different. So if you read the question, 600 picofarad is charged by 200 volt ka battery. Once it is charged, battery is removed, one more capacitor is connected, and that capacitor is 300 picofarad, not 600, identical. How much energy is lost during the process and what happens to the lost energy? That is exactly same as the previous question. Only difference is that both the capacitors are different. Let's analyze the situation. Let us draw the circuit diagram. Okay. So 600 picofarad connected to a battery, 600 picofarad connected to a battery of 200 volts. So what will be the energy stored in this? The E initial will be how much? Half CV square. So C is 600 into 10 to the power minus 12 V square, which is 200 ka square. So let's solve it. So this will become 300 into 10 to the power minus 12 into, this will be how much? 2 square 4 and 10 to the power 4. Perfectly correct. So 3 fours are 12, 10 to the power minus 6 joules. So this much energy is stored initially. Now the moment I remove the battery, right? This is our first situation. This is second. So in the second, what I am doing, I am connecting a 300 picofarad. Correct. So this is 600 picofarad and this is 300 picofarad. So this is plus, this is plus, this is minus, this is minus. Now what will happen? The first question, series or parallel? Answer is parallel. Simple method. If I make a point A here, if I mark a point B here, this positive and this positive have same terminal, this negative and this negative have same terminal. Two capacitors between the same terminals are parallel. Correct? Now the next thing, find out what is the common potential and find out what is the charge distribution. Right? This is the next question. So what is the total charge? We didn't calculate the total charge, right? So total charge is equal to C into V. So total charge, C is 600 picofarad, so 10 to the power minus 12. And what is the potential given? 200. I'm finding the total charge. So 6 2s are 12. 12 into 10 to the power minus 8 coulomb. Right? This is the total charge. And finally also charge will remain same. If I say the charge on this is Q1 and the charge on this is Q2, correct? So potential will be same because parallel. So what you will write, Q1 by 600 will be equal to Q2 by 300, right? Why? Because potential will be same, right? So 3 2s are 6. So Q1 equal to 2 times of Q2. So since we know law of conservation of charge will hold true, so what I will write, Q1 plus Q2 is equal to Q. So Q1 is 2Q2, 2 plus 1, 3. 3 times of Q2 will be equal to Q. So from here, what can we write? Let me write in the bottom only. So Q2 will be equal to Q by 3, right? And what will be Q1? Remaining charge. So Q1 will be 2Q by 3. So this is the charge distribution. See, in a very simple way, we found it. But if you observe here, the charge distribution is not equal because capacitor ka value is different. It is different. This is the charge distribution. And Q ka value to you have, na? You can put Q here. So 3 4s are 12. So this will be how much? 4 into 10 to the power minus 8. And this will be how much? 8 into 10 to the power minus 8 volts. So I found the charge distribution. Now the second thing what you need to find is the common potential. You need to find out common potential. So how will you find the common potential? You know C, you know charge. Find out potential. Na? So what will be potential? Potential V common. V common will be what? Q1 by 600 picofarad or Q2 by 300 picofarad. Correct? So let's calculate the value. Put Q1 if I use this one. So what will be V common? Q1 is how much? We calculate, right? 8. 8 into 10 to the power minus 8 divided by 600 into this. So this becomes 6 into 10 to the power minus 10. So this becomes 2 4s are 8, 2 3s are 6. 4 by 3 into 10 to the power 2 volts. This is the common potential. Okay. Now you have the common potential. You have the capacitors also. How will you find the total energy? Use half CV square for this. Use half CV square for this. C is 600 picofarad. Voltage is 4 by 3 into 10 to the power 2. Then use half CV square for this. Find out the value. Add. So that will be the final energy. When you will find the final energy, you will observe that it will be less as compared to 12 into 10 to the power minus 6. So what I want you guys to do, find out the energy in the second case. I've solved almost, I give the hint also. Find out the answer, write the answer in the comment box that what is the final energy, and the reason you already know that why the energy will be less, because when the charge distribution is happening, in that time there will be a transient current flowing, and because of that current there will be some heat produced, there will be some electromagnetic radiation. So the energy is lost in the form of heat and electromagnetic radiation. So these two questions were very good. In one way I can say that you learned a lot of concept, how to find the charge distribution, how to find the common potential, and how to identify series and parallel combination of capacitors. In the end, I will tell you one trick also to find the common potential, which you can use in your MCQs. Okay, so let's see the trick. The trick is, let me create some space first. So I will erase this part, or I will erase this part only from here. So all of you see the trick. The trick is V common can be written as C1 V1 plus C2 V2 divided by C1 plus C2. C1 V1 plus C2 V2 divided by C1 plus C2. So what is V2 here? V2 is the potential across C2. Initially, what is the potential across the second capacitor? Nothing, because it is discharged. V2 is 0 initially. When you connect this 300 to 600, what is the potential across this, boss? Nothing, because it is uncharged. So what will be V2? 0. What is the potential across C1 initially? 200. So 200 into 600 picofarad plus this becomes 0 divided by 600 plus 300, which is 900 picofarad. The moment you substitute this, you will get exactly the same value of common potential. So this is a shortcut which you can use, but you should know the method also. So on this note, I will end this session. I hope that you guys have learned a lot of new concepts. So prepare properly for your board exam. CUET Academy is with you. See you guys in the next session.